Hello and welcome to another Great Cow Basic training session. So today we are looking at data tables. Okay, data tables. Those data tables are a way of storing data efficiently in memory. And I've used the word memory specifically because we'll cover EEPROM and other memory tomorrow. So let's have a look. Let's have a look where we are in the session. We're at session 17. We're using tables, and tomorrow we'll be looking at EEPROM in terms of memory and other types of memory that are available on microcontrollers. With much more ado, let's get started. I have a PIC. It's a 16F 18313. By now, you think I'd know that. And it's connected to a programmer, and it's a PIC-Kit2 programmer. So what's the device? It's an 8-pin device. It's got 8 legs, and I'm going to connect an LCD to it, which we've done at session number 15. So I am going to be using the same LCD as previously. So what have we got here? We've got this low pin out board, and I'm going to connect the serial into this port here. That's already been pre-configured. I'm just going to take that from session 15. So why would you want to use a table? So a table, the use cases for table is really to minimize the amount of code you've got. You can use them to store configuration data, fonts, BMPs, sprites, all sorts of data, and I'll show you in a moment how much of Great Cow Basic has tables. So let's just have a quick look at that, actually, fact, okay? I'm just going to do a quick search in here. I'll get into the editor on the main screen. I'm just going to do a quick search in here, and I'm going to do a search for the word in table. I'll explain that in a moment. So it's it's rapidly going through. It's rapidly going through the search engine. So let's have a look at my desktop. There we go. It's searching through, and it's found a load of files that are out in your installation. These are demonstrations. So if I just show you one, for example, I think the sprite ones are pretty good because they show you how to. Let's just open that one up. I've opened it up by double clicking it, and in here there are some tables. All right, so let's cursor through. Oh, look, there's tables in here for the sprites. A sprite is something that gets drawn on a graphical screen. Okay, so let's have a look at some other usage here. Okay, let's have a look at this one. This is oh, there we go. Look, beautiful. That is a set of tables, and we'll talk about the construct of a table in a moment. So let's zoom in on that for you. I wish I could do that. There we go. Look. So if I just click here, you can see that by clicking that, it just highlights them. So that you can see there's two different shapes here, and this is a moving sprite. And so what this guy has done, he's defined a table of sprites. Okay. Let me have a look at the yellow. Oh, there you go. Look. Whatever this constant is here, and you can see that he's defined a set of tables. So what are tables? Okay. Well, tables are created in program memory, typically in program memory, or inside the chip anyway. I'll show you how to do that. And you can define that table using a couple of simple statements. And you can also import that from an external flat file. Okay, and you can also create a table by importing that from a BMP. So if I quickly just show you that, so you can do it in table as per here. You can do it in program memory. You can import it from an external source like a flat file, or you can do BMPs. There are many different others. So I'm just going to take you through the fast ones today. Okay. All right. Let's get into our program. So I'm just going to toggle into here and shut down these that were open. I'm going to take the training session 15, and essentially I'm going to take this whole program and I'm going to create a new program and paste it in. First of all, I'm just going to say, let's just put some text on there. tables, okay? And I'm just going to use the existing thing that we had before, but I'm going to I'm just going to do this for you very quickly. I'll explain it. Good. Right. Got my chip, and I've said option explicit, which means I need to define all my variables. I've connected the I'm connecting the serial module to the pin RA5 here. I'm specifying a baud rate, and I'm telling it it's an LCD with an I/O of 107, and that means that when I program it here, I need to save the file. We'll save that as a new file. I've just done that. Let's just go back to 2 cameras for you here. Great, there we go. We'll just program that, make sure it works. And down on the camera, we should get, oh, there we go, just said it, didn't it? Tables. All right, we should really have that slightly differently because I don't like that. Okay, using tables, okay, all right. Great. So what we've done is basically set up just the shell, and I'm going to go into and look at the help, okay? So if I just out of interest, if I type the word table, it will take, I can then press F1 and it will take me directly into the help. And if I maximize that for you, I can define a table. They're a single value on each line. They can be bytes, words, or longs, or integers. Strings must be as ASCII values, etc. And you can read this on your own. But let's just take an example of a table that's been defined by a set of values, and here they are. If I just take this and take it into our editor, then we can zoom in on it and see it a lot better. Okay, so let me zoom in on here. I've lost the focus of my brain. There we go. Okay, so I'm going to insert that into here. So how do we define a table? Because this is where we left it. This is the last piece of code that we just edited. So I'm going to insert code below here. And essentially, I start with table and then finish with end table. I give it a table name and then a set of numbers, and those numbers could, as I said, words, bytes, integers, and longs, etc. Okay. Now, I am going to put that out on the program that straight away. We can then see what's happening, and then I'll explain it. Great. So what it's done, it's taken the table data that we defined here, and it's displayed it out on the LCD. How has it done that? So this is the definition of the table. And we've got some variables that we're going to be using. Okay, that's table counter and in value. And I've iterated through the table by using the command read table. And I said read it from that data table. I have a pointer or a counter, so which element I want to read, which is 1 to 6. And then I say put the return value in value, and then I print it on the screen. And that's it. That's how you use tables. They're extremely simple. But let's just change our values here. No, let's not. Let's go over to the help. We'll just take about the help. Look, you can define tables using, they don't always have to be on single lines. They can be like this, look. They can be multiples on the same line. We'll just program that out just to prove it. And it says there's an error somewhere. So where's that error? Oh, there's an error there, look. I put an extra E in. And it should put that down onto the LCD. You might not believe me, so I'll change that last number to 99, and then we'll take it back. Once it's done that, I'm going to go straight into the help again, and I'm going to take another example. Okay, so into the help, I took this example, the second example. Let's take one where we've got calculations going on. So you can do calculations. Let me just paste that into there. Great. Zoom in on that for you. Great. And this one has essentially got a table that's been defined, and then it's got a multiplying constant called, well, that value is 2. So without looking at the LCD, I'm not looking at it. Oh, there we go. I've just seen it. It's taken the value of 1 and multiplied it by our constant of 2. You can set that to 3, and it will end up with 3, 6, 9, etc. So you can do some maths in here as well. So in the case of the sprite, it's a huge table that's coming through. So if we look at other options we've got, back into the help for you, you can actually source things from external files, okay? And here's an example. I'll take this example here, and it says, I'll go into SynWrite and paste it in so we can examine it a bit closer. I'll paste it into there, then zoom in. I'm sort of getting used to doing this now. There we go. It says define a table from an external file called source raw, and it's going to fail because we've got no variables defined. Okay, so let's just dimension some variables. Okay, let's call that in value so that at least we know it's the same as what we had before. And so what is in this source raw file? Well, let's open it up. I've got one open here. Where is it? Here. There we go. There. It's called Great Cow Basic. Let's change that to my name, okay? So just so that you know that it's doing it. Can't think of my own name. Save that, and I'm going to, what it will then do in our example here, it will create a source file. It will take this source file and create me a table. And there's no entry here in the source code, but we can see it do it in a moment. Now, then on the LCD, we get the startup, and then we get a load of numbers. That's because when it comes in as a load of numbers, it's in ASCII format. These are the ASCII values. So I just need to convert in my source code here to a string, to a character, and then I'll just send that back down. And then that 65, I know, happens to be an uppercase A, all right? Now, interesting, that stopped at 2020. It didn't say what I expected it to do. So let's just change our source code to resolve that, because I'm only reading in 10 characters here. So to do this, I'm just going to define another variable, because element 0 of a table tells you its length. Table length. So if I read element 0 in, it will tell me the table length. So I'm reading in from the same table element 0, and it will give me the table length. If I take that variable and put it as the last, the for next statement as the last element, it will then go to the table length for me. If I compile that up, I should get an Nebian 2020. So I've imported an external file into there. So finally, what I wanted to show you was importing a BMP. This is tricky. I cannot show you on the LCD, but we're going to do it anyway. So what I'm going to do is open up a demonstration. They're GCLC demonstrations. Okay, they are. I'm opening it up. The folders show This is BMP examples. No, I was looking at it this morning. Okay, so which one was it? This one here. Yeah, let's do this one here. Okay, what this does, this creates a table from a BMP file. I'll show you my desktop. The BMP file looks like this. In a moment, we're going to edit that. Okay, let's have a bit of fun. All right, so back into the compiler, into the tool here, and we're just going to make an assembly file, and you will see now on the screen, you saw an inverted picture of me on that screen. Let's just show you that lot, because it is. I'm just going to grab this in this little window here and then close it. Put it into here for you. Look. And what it does, it's automatically pulled it in for us. Now if I just click here, you can see that that's that picture, and it somehow created this table through what's called a converter. So if I open up this file here, I will see a table, and there it is on the screen. That is a table, and that table is enormous. Just to prove it to you, if we go into this here and we just edit, is that how you do it? I've never used this editor before. Okay, don't know. Let's just flip it around. There you go. Look. Save a copy. I don't know what it's doing. I don't like that at all, because let me edit the file in a proper editor like Paint. I like Paint. Okay, I can use Paint. It's sort of thing I use is Paint. Let me just set the line. I'll put some eyes on me. Look. Oh, there you go. Look. Some eyes. I'll save that away, and then back into our source, back into that demonstration, and you will see that I've got eyes that have appeared in that file. You can see my eyes there. Look, there is the eye on the screen. So, what are we trying to do today? We tried to see that we could create tables. We can do that by using table and end table. We can import tables from an external source, and we can also import PMPs. With that, I think we'll call that a wrap, because that's been a long old session today.